Hello everyone. In this video we're going to get an introduction to circles. That's going to include talking about the names of some segments within a circle, as well as some calculations that we can find with a circle, including the circumference and the area. So to get started, we'll just talk about the definition of what a circle is, and we can consider this to be a shape that either has no sides at all or an infinite number of sides. And the infinite idea would be if you had a shape and you just kept adding more and more and more sides to where it was such a large amount, and when those are all connecting together, because there's so many sides, you end up just getting a rounded shape. Quite often, though, we just say that a circle has no sides at all. So to make one, which we'll see soon, the idea is you need to know where the center of a circle is, and there is a true center in a circle. And to make this circular shape from the center, you create a set of points that are all the same distance away from it. So we can see this blue radius right here from the center to the circle. If we can take this radius all the way around the circle, and this radius is not changing length as we do that, we would know that every single point on this circle is the same distance away from the center. And because that central point is so important, it's the same distance away from each part of the circle. That's how we also name the circle. So if we were to give this circle a point here in the center, and we called this A, then we would name this circle with a circle symbol showing the center and A afterwards, and that would be our way of showing the name circle A. All right, so fairly simple. Let's just kind of go through here. What do those segments mean? How do we identify them? So just a quick match here. If at this point you want to pause the video and go ahead and match these definitions yourself, you can. So if we go through one at a time here, we see the first definition says the segment that reaches from the center of the circle to the outside. So the segment that goes from the center directly to the outside we see is called the radius, and that would be option D. Okay, the next part says the measurement around the circle, similar to the perimeter of a shape. So circles don't have any sides. Perimeter is what you get when you add up side lengths. And since we don't have sides, we give it a new name. And this is called the circumference. The segment with both endpoints on the circle, that's a generic definition. Any segment out there that has both endpoints on the circle, such as this one, is what we call a chord. So any segment where that happens, where each endpoint is on the circle, we will call that a chord. All right, and lastly, a chord that passes through the center of the circle. So it is a chord because both endpoints are on the circle, but it goes through the center. That's what we call the diameter. So one last reference up here. The diameter does have two endpoints on the circle, but it also goes to the radius. So at that point, it gets a special name, and if it doesn't, we just call it a chord. Okay, so just some trivial information. Hopefully we remember some of this. Some of it we might process, but it's the always, sometimes, never questions. So I've got looks like 7 prompts here that we'll identify to be always true, sometimes true, or never true. Again, if you want to pause the video at this time to try that yourself, feel free and do that now. If we go through each of these, let's go ahead and think. The first part says we have a chord of a circle. Does it have to be the diameter? Can it be the diameter? So if we have a chord, is it the diameter? Well, a chord does have 2 endpoints on the circle. So does a diameter. So it could happen. But a chord in general does not have to go through the center, and a diameter does. So this is sometimes true. Looking at the next one, it says a diameter of a circle is a chord. Well, we know that every diameter has to have both endpoints on the circle, which is the definition of a chord. So every diameter that we have would be a chord. A circle has different radius lengths. Well, that goes against our definition of how to construct a circle. A circle is a shape where every point is the same distance away from the center. And if that's true, the radius can never change in size. So any circle you have, the radius must stay the same length. So that is never true there. A radius of a circle is half of its diameter. That is true. The radius and the diameter both utilize the center. The radius is directly from the center to the outside. The diameter is all the way across the circle. So yes, the radius is always going to be half of the diameter length. Two chords in a circle are congruent. We know congruent means that they'll be the same length. We could take a look up here at our diagram. You have this chord here in a yellowish color. I could draw another chord here, and we can see that while this is also a chord, it is not as long as the other. And so, no, chords do not have to be the same length, but it is possible to where that could happen if we made another chord down here that was about the same length as the yellow chord up there. Okay, so yes, chords can be the same length, but there's no guarantee that they will be. So this is a sometimes. Two diameters in a circle are congruent. Well, every diameter you draw in must go through the center. So because every point on the circle is the same distance away from the center, the radius is always staying the same length. It's going to turn out the diameters are always going to be the same length as well. So that is always. And lastly, a radius is a chord. A chord has to have both endpoints on the circle, and a radius must have one of its endpoints at the center. So it is impossible for a radius to ever be a chord. So that is never. Okay, so there's just some thinking questions about what the definitions of some of these words are, and how some of these segments might relate to each other. So later in the unit, we'll talk about more of how these particular segments might tell us a little bit about our circles. Today, we're just going to name them and utilize them in a familiar way. So I thought one thing we could do if you're in the classroom is actually get out one of the old compasses with the pencil to trace what a circle is so that you can see it being formed with that space from the center to the outside. Because I'm doing this on a computer, I don't have that tool available, but I do have GeoGebra. So right now, we're just going to make a circle, and we're going to practice showing a few things. So first off, we're going to use a compass to construct a circle with a set radius length, just meaning choose whatever length of radius you want, but don't change it as you're tracing out your circle. So in GeoGebra, that's pretty straightforward. You choose the tool that says circle with center. You click for your center and you drag out to however big of a circle you want. And there will be my circle. So A to B would be that distance from the center to the outside, a radius. And any point on the circle should be the same distance away from A. All right, so I have my circle there. And then the next thing is I'm going to show the center to be P, a little simpler. If I am just doing this with a pencil on paper, but we can still change this. We right click here, settings, and I can change the name. So there is the center, P. All right, now we're going to construct a diameter AB. Okay, so we do know that the diameter has to go through the center. I already have B on here, so if I were to draw a line here, that way I know that this line definitely goes through B and through the center. Now I can show a point over here where this line touches the circle on this side and connect from A to B, and there's a diameter. Okay, I went ahead and hid that line then since I have my diameter AB. Now I'm going to show a radius PC, so this radius needs to go from the center to a different point C, which we have there. So now I'll draw a segment from P to C, and I have another radius. So right now in the picture we do have 3 radii, right? From P to A, P to C, and P to B, and I know all of those are going to be the same length. And lastly, let's make a new point, a chord. Let's make a chord XY. I haven't used either one of those points, X or Y, so I'll make 2 new points here and here. Let me rename them. And now that I have those, let me draw a segment from X to Y, and there would be a chord. All right, I'm going to change some colors here to make them stand out. And let me go place this into my notes. And it looks like I've shown everything that's listed here in my circle, and our construction is complete. Okay, so there's just some practice of names and the idea of some of the properties a circle has. So the last thing I thought we could do today is refresh on some formulas that we've probably seen in elementary and middle school so far. We already talked about here, how does the diameter relate to the radius? 2 ways to think about it. You can think of the diameter being twice the radius, so D would be equal to 2 times whatever your radius is. Or you can think of that as the radius being half of your diameter. So your radius value is whatever your diameter is divided by 2. Circumference, we said already, is the distance around the circle. I'll tell you this, they are given like this on formula sheets without the dots even. It just says 2 pi r like this. Okay, so that's how the formula sheets always give them to you, which does mean multiplication. But when we write answers, we put pi at the end of them. So I thought it might be nicer if we had this to reference, which is really the same thing. We know the order of multiplication doesn't matter, but this one is much friendlier in terms of its setup. The same would be down here. If we put pi at the end of our answers, we might as well go ahead and set the formula up that way. So circumference can be found using your radius or the diameter because we already know how those relate to each other. So if you have your radius, pretty simple, just take 2 times the radius times pi. To find circumference using your diameter, not too a little bit simpler, I suppose. You just take your diameter times pi. So pretty easy there. All right, and then the last thing would be the area, which you've probably seen before. Area equals pi r squared. Again, formula sheets would just list it as this, but that still means multiplication. But again, since we include pi at the end of our results, it's nicer to realize that we can set up our formula like that with pi at the end instead. Okay, so let's use those properties down here on a few examples, and we should be good to go until next time. So example 1 asks us to calculate the exact and the approximated circumference. So let's talk about what the difference there is. We know circumference uses pi in the formula, and we know pi is an irrational number that continues on infinitely. So the exact answer is going to leave pi in the answer. The approximated would be using a decimal approximation for our value of pi. So in this circle, we see there is a segment going from the center to the outside. That would be your radius. So the radius here is 12, meaning when I use a formula for circumference, I'm going to use the one that involves the radius, which is 2 times your radius times pi. Pretty simply here, that would be 2 times 12 times pi. And the easiest thing we could do for an exact answer would be multiply 2 and 12 together to get 24 and leave pi in our answer. So the exact answer is what we just got there. The approximated value would be what we get when we use a decimal for pi. So we all know 3.14. It does go on further than that. So if we go here to a calculator and we type in 24 and we're going to multiply by pi, you're going to see there is a pi symbol. And there you go. So our approximation here is 75 point several decimal places. Maybe we just go to the first decimal place for right now and we just say 75.4, right? So 0.39 would round to 0.4 if we stopped at the first decimal place, the tenths value. So there's the difference between the exact and approximation, whether we keep pi in our answer or we use a decimal value for pi. Okay, number 2. Another question about circumference, just the exact circumference for this one. And to find circumference, we either need to know the radius, like we did in the first problem, or we need to know the diameter. It turns out you don't know either in this scenario, but you do have this segment drawn through the center in the diagram. So we know that this is your diameter. And if you look closely, you're going to see that there is a right triangle here. So hopefully you still remember, with a right triangle, to find a missing side length, you can use Pythagorean theorem, which is what we're going to do. So Pythagorean theorem here, your hypotenuse is always the c value. So my diameter is the hypotenuse. And then we have 6 squared and 8 squared on this side. Let's get those squared values. That'd be 36 and 64, which we see is 100 when we add. And we find that 100 equals d squared. So d is equal to 10. Right? We could do that hopefully from memory, but if not, if we take the square root of each side, we would see that's true. Okay. So we have a diameter. We have a way to find area or circumference using that diameter, right? We know circumference, capital C for that, is your diameter times pi. And so for us, that would be 10 times pi, which shorthand would just be 10 pi. Okay, so a couple scenarios finding circumference. Last 2 examples then. Number 3 is going to involve multiple circles, and all we're going to do here is talk about how we can find a segment length. And in the last example, we'll talk about area. So let's look at example 3, and we will see that we have these circles and some information provided. We know the diameter of circle A is 30, and the diameter of circle B is 16, and the length from A to B is 28. So let's think this through. We are told, once again, that the diameter of circle A is 30. Well, you notice in circle A, we don't know the diameter, but we do have this length going from the center to the outside. In other words, the radius. So if the diameter of circle A is 13, then the radius is going to be 15. Sorry, if the diameter is 30, the radius is half of that, 15. In the other circle, circle B, we know the diameter is 16, which would mean that the radius here is half of that. So the half of 16 is 8. And we are trying to figure out how far it is from C to D. So maybe I put an X there. We're going to figure out that length. And we wouldn't be able to do that if we didn't know this next part that says from A all the way over to B. So from A all the way over to B is 28. Well, this is actually just a review of some of the first concepts we ever learned in geometry of segment addition postulate, little plus little equals big. In this case, you have 3 pieces. So if we take our 3 smaller segments there, we should know that 15 plus x plus 8 must equal 28. So some simplification there, we get 23 plus x is 28, which is going to tell us that x is 5, and we recall that x is that space from C to D. So just a question that relates diameter to the radius. You see these kind of questions pop up every now and then. Sometimes the circles overlap each other a little bit, so instead of adding everything together, we have to subtract somewhere to find that space that we're looking for. But a lot of similar concepts involved. All right, the last case we have area. We know the formula from area from up above says that the area should be your radius squared times pi. If you look at this diagram, we do see that this segment goes all the way across. So this is your diameter, and we know that your radius would be half of that. So the radius in this case, we know is half of your diameter. So the radius would be 18 over 2, which is 9. So for our area here, we have area equals radius squared. That's going to be 9 squared times pi, which is going to give us 81 times pi. And that's going to be our area here because we were asked to find the exact area. So the exact area here, 81 pi. In terms of units, area in any scenario is always squared units. So this is inches squared, squared inches. And that is also true. Similarly, for number 1, this was not area, this was distance around the circle when you find circumference. And distance is just in inches in this scenario. So non-squared units. All right, and that's where we'll leave it today. As we continue throughout the unit, we'll get into a little more of some special segments within circles and also parts of the circle itself.